ax plus by equals c, standard form. What other forms do we know?
None.
What else do we know?
Y equals
K equals
Y equals
Fine,
X.
one at a time. One at a time. So Claire, y equals mx plus b. What's the name for that form? Not what I'm looking for. Anna? Slope-intercept form. It is in function form. We call this slope-intercept form. Why? Because we have a slope, we have an intercept. What's another form? Alex, what's a
KX.
Well, y equals kx is a variation of this. It's direct variation, right? Okay. It is a form of slope-intercept, but it's the same form. There's a whole other form we have, yeah? Point slope. And what does point slope look like? You remember?
Y minus y1
You got it.
equals in parentheses x minus x1.
Nice. Very good. All right, so there's three different forms of this line.
What about?
Should I left it on Ms. Orr because it stopped talking? Okay. So three forms of a line. So let's identify which form we've got here. What form is this? Which is called what? Slope-intercept form. And then what form is this? Point slope. And then, I don't see standard form. Yeah, here's standard form, right?
Is it? Wait, isn't that the same thing as the slope and the slope? Yeah.
What? Say it again?
Isn't that the same thing as slope and the slope?
Isn't that the same thing? Right? How did I get there? I just added this, right?
Yeah.
Well, what about this one? Let's see. Y plus 3 equals negative 2x plus 4. Subtract 3?
Yes.
Hey, wait, that's the same thing too.
How would you like that?
Okay, they're all the same thing. It's like, it sounds like an obvious sort of thing. They're all the same thing, but I've just written them in three different ways. You write them in three different ways. Does it make them different? Just the way they look?
No.
But they are the same. If you were to graph any one of these forms, you get the same line. Same solutions, right?
Yeah.
So don't get lost in there like, oh, this one, they're different. They are the same. Same, same, same. Now there's different uses for these forms. We have these different forms because they're good for different things. This is certainly great for graphing, isn't it? This one is also good for graphing if you use intercept method. There's other things you might use with this. This is good if you have a point slope and maybe you want to get to a different form. So they each have their place. They are the same. Don't forget that because that's one of those things we tend to forget. So let's look at standard form. Now what you can do with standard form is something interesting. You can multiply or divide both sides of an equation by the same number. And if you do that, you get an equivalent equation. And what do I mean by equivalent equation? Well, it's the same, right? The equations mean the same thing. Just like here. These are all equivalent equations. Well, I can have other standard forms that are equivalent. So let's look at this one. I've got 2x minus 6y equals 4. Now, is this legal to do something like this?
Yeah.
Who says I can multiply both sides by 2? It's still equal. What property? Multiplication property of equality. So let's do it. So 4x minus 12y equals 8. These are equivalent. If you were to graph these two things, you get the exact same line. Equivalent. Same. You can also use the division property of equality. What if I divide everything by 2? I have another equivalent equation. Can you come up with another equivalent equation? Multiply by 4. Let's change these to 4s. So what do we get? 8x minus 24y equals 16? Equivalent. Yes, sir. By what? 3/4? multiply by 3/4. All right, 3/4, huh? Geez, it's challenging me now. So let's see, what's that one? 6? 6x minus what? Oh. Why are we doing 3/4, Jerry? 9/2 equals 3/4. 3? I may have made a mistake here. Did I do it right? But you know, he's right. You can multiply by anything you want. So here's my question. How many equivalent equations can I create? Infinite number. Because you can multiply or divide by an infinite number of them. Yes, you can. So here's what you try. This is on your paper here. It's where it says examples. A was the one we just did, 2x minus 6y equals 4. B, come up with just 2 equivalent equations to negative 3x plus 9y equals 27. Who's got some equations for me? Yeah, give me one.
Negative 9x plus 27y equals 3.
How'd you get that? Multiplied everything by 3. Who's got another one? Yeah?
3x minus 9 equals negative 1.
Okay, Claire, tell me what to do here.
That's a plus sign everything by 3.
Yeah, multiply through by negative 1 because that just flips our sign. Yeah?
I'm confused. Why did she do it by 3 and not negative 1?
You get to choose whatever number you want.
Oh.
Yeah, I'm just saying come up with 2 equivalent ones. Now we've got an infinite number of them. You may not have chosen the same one she did.
So you can just do any number.
Any number. Yes.
Oh.
Yes, sir.
I divided by 3.
What'd you get?
Negative x plus 3y.
Excellent. That's right. You can divide as well as multiply. Now when did we do multiplying like this? We have done this.
Oh, it was for the...
Oh.
I don't remember.
You don't remember? When did we do? We've done this. We've done this.
That, whatchamacallit?
You guys. Now whatchamacallit
It was the it starts with an E.
elimination method to
Yeah.
solve a linear system. We've done this. We have done it.
Yes.
So that's all we're doing is just refreshing our memories. All right. Okay. So, since I have an infinite number of solutions, we have this idea of a simplest form or a best form for a standard form of an equation. It's kind of like reducing a fraction. Because like 3/4, how many different ways can I express 3/4 of something? I can say 3/4, 6/8, right? How many different ways can I do that? A lot. Infinite number. We use lowest, simplest form so that we all talk about the same thing. So let's just review how that works. Coefficients have to be integers. What is an integer? What's an integer, Jerry?
All negative numbers, 0, all positive numbers.
All of them? How about this one?
Including decimals, fractions.
Excluding decimals and fractions. Right? So this is not an integer. So I'm looking here. Does this meet this condition? No. How do I get rid of a fraction? Well, multiply. Let's just multiply by denominator. Right? So if I multiply, am I allowed to multiply everything by 2? Yes. So I get 2y equals x minus 6. Oh, you know what? I forgot to put it in standard form. Is this standard form? No, let's do that. I'm going to do that first because I forgot to do that. And then we'll come back and do that again. All right, so let's put it in standard form. Now, standard form, this is slope. Oh, what happened to that? This is slope-intercept form, right? Isn't it? Isn't it? All right. How do I turn slope-intercept into standard form? This x term has to be moved to the other side of the equal. How do I move it over? Subtracted minus half x minus half x. Now remember our little shortcut of to move terms to one side to the other, they change sign. So is this standard form? Yes. But is it best form? Are all the coefficients integers? No. Now common greatest factor among the coefficients is 1. All right. Coefficients are what? What are coefficients? Right, the number that you're multiplying that variable by. It's in front. So this one has an invisible one as 1, right? What I basically mean is, can I reduce? Is there a common factor in here? No. And the leading coefficient. What's a leading coefficient? The first one. So if you're in standard form, it's this one. It has to be positive. Is that true? All right. So let's deal with one at a time. We already discussed multiply by 2, everything. So what do I get? Negative x plus 2y equals negative 6. Takes care of this problem. Can I reduce anything here? I've got a 1, a 2, and a negative 6. What's the common factor in all those numbers? 2. And what about 1? 1. I can reduce it. So I'm meeting this condition. The leading coefficient has to be positive. Is that true?
Multiply by negative 1.
I can't have fractions, right? Only
You can't
integers.
reduce it by
Okay. Am I meeting all the conditions now? Coefficients are integers.
Yes.
I can't reduce them. And what I mean by that is if you have something like this, is this reducible?
Yes.
Because it has a common factor of 2. This doesn't. Good. And I've got a positive coefficient. We'll do a couple of other ones of these just to see what we simplest form. Now, is there anything wrong with this one? No. If I asked you, give me the answer in standard form, and you gave me this, you're correct. Well, I don't know if I want to take points off if I didn't say put it in simplest form. However, what if there was a multiple choice question? Put this in standard form. Would you be able to recognize that this is the answer? So, I don't want to say you don't have to do this, but you have to recognize that there's many different forms and how to get there. So, we'll be practicing doing this. Now, we already know how to do 2/3 of this, which is write an equation given a line. At least I hope we do. First thing you do is find the slope. And what's the slope? Go up 3, then what?
Negative 2.
Left was -1. Slope is -3. Now I've got 2 points. How many points do I really need?
1.
And then I can do point slope, because I'll have a point and a slope. Which point? Which point do you want to use? One. Y minus y1 equals m times x minus x1. This one's nice because you can't fix them all. So it's a good choice if you have to pick. Y minus 1 equals negative 3x, negative 3 times negative 1 plus 3. Add 1 to both sides. Okay, this is nothing new, right? We did this. Here's the new piece. How do you rewrite this in standard form?
Is that like
You subtract, you add 3 and
Is what? Is what x equals? Sorry? Well, I was just, what's the question? You sure? Yeah. Move that guy over. And now I'm in standard form.
Oh, so standard form is just moving the axis.
Just move the x over, you got it. Now, is this best or the simplest form? Well, let's see, do I have any fractions?
No.
Can this be reduced at all?
No.
No. And is it positive up front?
Yes.
I'm already in best form. That was really cool. Yeah. Well, so, no. That was way too fast. Okay. Okay, so now I'm giving you 2 points. Again, we know how to do this, don't we?
Yes.
Yes. How do you find this slope?
Y1 minus Y2.
Y2 minus y. So what is this? Negative 2. Negative 1 is 2?
Yep.
Yes.
To find this up, can you also do it as like the Y1 minus, like Y minus Y1, and then this off the end? Like, and then like.
Yes, that's what we're doing. That's exactly what we're doing. We're solving, this is y2 minus y1 over
And then
x2.
I mean like, the Y
And point slope?
minus Y equals M.
Well, I don't know m. I can't go to point slope yet until I know m.
No, but then if you just plug it in, can't you find
But
M?
then I've got 2 unknowns. It's like too many things missing if I don't know m first. So you do kind of have to do this. Find m first, and then you can go to point slope. Because if you don't, you're going to have, I don't even know. Oh, okay. If you're just saying use slope, all right. I think now I understand the question. Use slope, but write it as like this.
Yeah.
Yes, you can do that and solve for n. That's equivalent to what I just did. Yeah, you can do that if you want to. Which point do you want to use? You have to pick one.
3 negative 1.
3 negative 1. Okay. She said it first. Y minus y1. y1 is minus, so that's a plus. Slope is 2. X minus 3. distribute, and subtract 1. Okay, great. We know how to do this already. This is the new piece. How do I put this in standard form?
You have to subtract the base from 2 sides.
Move it to the other side by subtracting it over. Am I in standard form?
You're in standard form.
I am in standard form. What would be the best form? Is it in best form? No, what's the problem with it? Leading coefficient is negative. How do I fix that? And what does that do to you? It will flip all my signs. Well, the slope is 2, right? I just used y2 minus y1 over x minus x. So again, we know how, not hard.
That's why you
So we kind of, we're using everything. And you know, there are cases where this is, I don't know, better, but maybe you want this one as opposed to another one. Let's see what time it is. Ooh, it's time to go. So when we come back, we'll work on this a little bit more. Okay. All right, vertical and horizontal lines. So we kind of talked a little bit about this during the warm-up. So y equals a number. A is just some number. What's that going to look like? Horizontal or vertical line?
Horizontal.
Y equal is your horizontal line. X equals a number. What kind of line? Vertical line. Right? Questions on how I know this?
Nope.
Anybody with questions?
No.
Okay, so let's see if we can write. Now you don't have color on your papers. You're going to have to look up for a moment. What is the equation of this red line? I want the equation of this line. It is an undefined slope.
X equals 4.
How'd you get that?
Because it's 4 squared over.
Well, but why isn't it y equals 4? And how do you know what it is?
Because it's with X.
Because why? Look at how you're absolutely right. I just don't know the word.
She's standing on the x-axis.
I'm not on the x-axis.
X-intercept.
X-axis is right here.
X-intercept.
The x-intercept is here.
I have no
How do
idea.
you know that he gave me the right equation? He said it's x equals 4. How come?
Because it's vertical.
Because it's vertical. And then think of the other points on here. This one is 4, negative 1. This one is 4, negative 3. X is 4. Vertical lines are x equal. What does x equal? 4. All right? How about this blue line right here? What's the equation? Don't shout out. Hands up. What is the equation of this? What is it, Claire? Tell me how you got that.
I looked at the line. I saw that it said
Horizontal line.
so I knew it was y.
We know it's y equals, yeah.
And then I looked at the point. I got that. Right.
Yeah, and we say, okay, what is y? Y is negative 4. There it is. So, is this hard? No. Not really. Not if you understand x equal is vertical, y equals horizontal. Here's a point. I've got a point, negative 4 comma 10. What's the equation of the vertical line that will pass through this point? What do you think it's going to be? Please don't shout out. Raise your hands. What's it going to be, Andrew?
Negative 4.
What? That's not an equation. Negative 4 is not an equation. What is the equation of this line, Anna? Does x equal 10? Well, it's x and what's y? You're right. It's an x equal. Why is it an x equal? Because it's vertical. Well, let's go see. What is x equal to? Negative 4. What's going to be the equation of the horizontal line? Alex, what's it going to be? Y equals 10. Now tell me how. Right. Yep. And then y is 10. So given that point, it almost writes itself. Almost. But you have to know that the x equal is the vertical, the y equal is the horizontal. Alrighty, so where have we been? Standard form. Again, we know this already. ax plus by equals c. We kind of know this already. We get an equivalent equation by multiplying and dividing both sides by the same number. We've done that many times, especially with linear systems and the elimination method. We can write an equation standard form from 2 points by finding the slope and using one of the points the point slope form, but we've done this part. We've done all of this already. What's new? Converting it to standard form. That's the only new thing. And how hard is it to convert something to standard form? I'm going to take the general equation, y equals mx plus b. How do I make it standard form? Right? Subtract and move it over. Works for anything in slope-intercept forms. Horizontal lines are of the form y equals a, and vertical lines of the form x equals b. We know that too, right? We've done that a lot as well. So this is all just kind of taking things we know and just looking at it slightly differently. Okay, so let's look at the other side now. We're going to be working with parallel and perpendicular lines. Now you know a lot of this too. You know this. We already know that parallel lines have the same slope. Is that you, Sean? Nice. Same slope. Because think, if they're tilted the same way, they're going to be parallel. Now this little thing here, these three little dots, that's math shorthand for the word. It's not in yours, but it's in mine, so I'll just in case you see it again. It means therefore. So if you see this, if you don't feel like writing therefore, you can use these three little dots. So we already know that parallel lines have the same slope. Therefore, two linear equations that have the same something are parallel. Slope. Right, slope or slope. Okay, so for example, now these are very common questions. You not only see them in Algebra 1, they're all over geometry as well. So if you get it now, this part of geometry is snap. And this will be a snap here too. We're going to write an equation of a line that passes through point -3, -5, parallel to this other line. Now, let me just draw a picture to kind of show what I'm actually asking. These are meant to be the axes. A little crooked. I'm going to graph y equals 3x minus 1. The y-intercept is at -1, and my slope is 3, right? So up 3, right 1, up 3, right 1, right. So I've got this line, y equals 3x minus 1. Now what do I want? Otherwise, I want another line. It's going to go through this point, -3, -5, and it's going to be parallel to the other line. So I'm looking for the equation of that red line. That's what I'm trying to do. Do you have an idea, Alex?
Yeah, I do.
Well, I don't want to hear you. Tell me, talk it through. What would be the process?
Well, first we have to find the slope of the first line.
Okay, what is the slope of the first line?
3.
So what's the slope of the red line?
3.
3. Why?
Because it's parallel.
Because they're parallel. And parallel lines have the same slope. Excellent.
Then you put in point slope formula.
Okay, so what's my point?
You have y.
Okay, well, what points am I using? What points am I using? And then that's my slope. I have a point, I have a slope. Point slope. Yep, so tell me what I do now.
You put enter in the y plus 5 equals 3. Get x plus 3.
Right, so we're just using point slope formula. Yes?
Y plus 5 equals 3x plus 9.
Yeah.
And then you get 3 minus 5.
Subtract 5 from both sides.
And you get y plus 3x.
Wow, that was fabulous. Virtual gold star for you today. That was terrific. How do I know I've done this right? Is this line and this line parallel? How do I know they're parallel? How come? Excuse me, without shouting out. Claire, how do I know they're parallel lines? The slopes are the same and the y-intercepts are different. How do I know it passes through this point -3, -5? Well, let's plug it in. So -3 times -3, -9 plus 4, that's -5. It works. Excellent. So point slope form to find parallel lines. This kind of question, find it and put like this around it. Whoops, I'm trying to put a box around it and I'm messing it up. But you will see questions like this, very common type question. Is it hard? No. Good. Well, yeah, and then, so I think the picture helps. This is exactly what they want us to do. All right, now, that's parallel. Perpendicular is something else. What do perpendicular lines look like? Emma? They make 90-degree angles. And we use this little box to mean perpendicular. So if you see that little box, these are 90 degrees. And then they're actually all 90 degrees. If you have one of them, you have 4 of them. So that's perpendicular. So how do I know if lines are perpendicular? This is trying to explain it. It can be a little bit confusing, but let's start with this one. I've got a line with a slope of -3/2. Now if I'm going to have a line that's perpendicular, at a minimum, if this has a negative slope, what's the slope of this one going to be? It has to be, right? Opposite slopes, negative, positive. And then what we're doing is we're kind of turning it around. So instead of going down 3, right 2, I'm going to go up to left 3. It's kind of off. Here's like maybe this picture's a little bit better. I go up to right 3 and kind of turn it on its side. I'm turning it on its side a little bit. It's a little hard to see. But, so I go from -3/2 to a 2/3 as my perpendicular line. Yeah, what's going on here, Alex? So we flipped it, but what else did we do? And we made it opposite sign. So perpendicular lines have slopes that are negative reciprocal. You can also think of it as if you multiply the slope of the first line by its perpendicular line slope, you will get, well, let's cross out, that goes the right way, -1. So they're negative reciprocals of each other and their products are -1. Perpendicular lines have slopes that are negative reciprocals. So let's review. Parallel lines, same slope. And in perpendicular, I'll use this symbol means perpendicular because it looks like perpendicular lines. They are negative reciprocal. Let's play with negative reciprocal a little bit. What is the negative reciprocal of 4/5?
-4/5.
Without shouting out, okay? So what was this one, Jared?
-5/4.
-5/4. So you invert, right? You switch places, opposite sign. What is, no, don't shout out, negative reciprocal of -1/3? Andrew?
-3/1.
Well, you did the flipping. That's part 1. What else do you have to do? Opposite sign. So a negative reciprocal doesn't mean the number is going to necessarily be negative. It just means it's going to be opposite. Yeah?
Here's the number like 6 would be -6.
What's the reciprocal? Or that's the next question, isn't it? Let's do a different number. What's 10? Well, that's right. So it's 2 steps. Yes, take the opposite sign. Now picture this as being 10/1, right? Turn it over. Negative reciprocal. So what is the negative reciprocal of 6? I'll ask you that now. What is it? -1/6. Questions about negative reciprocal? Because if this is a sticky point, the rest of this becomes hard. Yeah?
The whole thing is just confusing me.
Which part? I need more than the whole thing is confusing. Can you give me a specific question?
Why you change it from like 6 negative?
Because perpendicular lines have slopes that are negative reciprocal.
Zero.
They have to be opposite. We can see why the signs have to be opposite, right? Go back to our picture, right? Why do the signs have to be opposite? If this is negative, this one's positive, right? Should be perpendicular. Perpendicular, making 90 degrees, right? And then, so you're kind of going up and over in the opposite way to get it to tilt that way.
And then you're basically,
The opposite, yeah.
so if it was like -6/7, it would be +7/6.
Yes. I'm sorry, Jerry, what were you saying?
The opposite would be the other side, not the opposite. You have to change the side.
Yes. Yes.
Yes.
Yes. Because you're turning them around. So it's a little hard to see it. I don't blame you. It's a little hard to see why it's a negative reciprocal, but it is. Okay. So how can I tell if lines are perpendicular or parallel? Let's remind ourselves. Parallel lines, same slope, right? And then perpendicular lines,
Negative reciprocal.
slopes are negative reciprocals.
There's only one line, so.
But I've got 3 lines right here. I've got line A, line B, and line C. And I want to know if they're parallel or perpendicular. What is my first step?
Well, there's a form.
Same form, because what am I trying to find, Emma? Slope. Exactly. Now, what's the slope of line A? Right, that's nice. It's in slope-intercept form. How about this one? We got to play with it a little bit. So 5y equals -x + 2. Let's divide everything by 5. So what's the slope of this line?
Negative 1/2.
Negative 1/5. Let's look at this guy. Well, let's put it in y equal form.
Negative 1.
Hang on. What's the slope of this line? Okay, let's start with the parallel question. Do I have any parallel lines here? Which lines are parallel? Y. Same slope, and they do have different y-intercepts. You can see by looking at that in y form. What about perpendicular?
A.
A is perpendicular. Why is A perpendicular to B? Jerry, why are these? Let's start with just A and B. Why are A perpendicular to B?
Negative
Yeah.
5.
That's right. What is the negative reciprocal of 5?
Negative 4.
And look at that. Who else is perpendicular to?
A and B.
Right? Because they are negative reciprocal. These two lines are parallel, and they're perpendicular to line A. Make sense?
Yeah.
Questions? Okay, so you're going to be doing a lot of slope work. Okay, now this question should look similar to the question we had earlier, except there's a word that's different. Write an equation of a line that passes through point 4, negative 5, and is perpendicular to this line. Now before, we were working with parallel. Now it says perpendicular. So anybody have an idea how we can start this? What do you think, Alex?
Oh, you're finding negative reciprocal.
Well, first of all, I have to find the slope of the original line, right? And you know what, let's draw the picture. We should really draw the picture. Y equals 2x plus 3. Y-intercept is 3, right? I go up 2, right 1, up 2, right 1, down 2, left 1. So here's my original line. What am I looking for now? Whoops. Point 4, negative 5. That's over here, right? Somewhere? And now I want perpendicular. So I'm looking for, exactly. So right away we can tell that since this is a positive slope, I know that this is going to be a negative slope. But let's find the slope of the original line. What is the slope of the original line, Jerry? 2. Y equals mx plus bn is 2. So what's the slope? Raising your hand now. What's the slope of the perpendicular line? I'm going to go to this side of the room, but also right over here. Ishan. Hello. What is going to be the slope of that perpendicular line if the original line is 2? Well, negative. It has to be opposite. What else has to be opposite? What's a reciprocal? Turn it upside down.
Oh,
Right. So you're just going to, it's 2 steps. Change the sign, turn it upside down. Great. Now what do I do? So what is the slope of this line here, of the red line?
negative 1/2.
And do I have a point on that line?
No.
Yes.
Negative.
I have a point and I have a slope. Point slope. So y minus y1 equals m times x minus x1. So let's see, my point is 4, negative 5. So what do I have here? Y plus 5. What's my slope? Which slope do I use, the 2 or the negative half?
Negative 1.
What? Which one do I use?
Negative.
Why do I use negative half instead of 2? Because I want the perpendicular line. If I use 2, what would I get? I would be getting the parallel line.
Yeah.
So let's see, x minus 4. So y plus 5 equals negative half x, negative times negative, right? Positive. Half of 4 is 2. Subtract 5, subtract 5. Y equals negative half x minus 3. Do I have a negative reciprocal slope? Yes. If I plug this point in, if I plug 4 in, will I get negative 5? Well, negative half of 4 is what? Negative 2? Negative 2 minus 3, negative 5. So I know I have the right graph. When you do these questions, I would really recommend underlining or circling what they're asking you for just to keep it straight. Because this question could have said parallel. Sometimes they'll say both. You have to find both lines. Questions on that? Yes?
When you're finding the equation for like a perpendicular line, can't you just like make the y-intercept negative and then like slope the
y-intercept should be negative what? But it's not. This is not a y-intercept, is it?
No, I'm talking about the y times
This one?
yeah.
Why would I do that? This one, I don't think it's necessarily going to work out that way. Where did we do? I thought we had a different example. Maybe we don't. I do have some U tries here, so we can do those on the bottom here. Now, be careful. A and B parallel. So what are you going to do here? You find the slope of this line, right? And use it. This one is perpendicular. So what are you going to do differently about these questions? Nobody knows? You're going to find the slope and then find the negative reciprocal and use that here with point slope. Now give these a try. All right, let's see. Some of you it's just there. You got it. Some of you are thinking a little bit more, which is okay. Oh, and it said put it in standard form. Did you do that?
Sure.
Did you put it in standard form when you were done?
Yes.
All right, first of all, shh, quiet please. So y equals negative 2x. Did we get there? Yeah. Right, your slope is negative 2. You use this point slope. You should have gotten this. I added 2x to both sides, 2x plus y equals 0. This one, oh, we had to figure out slope. So y equals 3x plus 7. So I got a slope of 3. So there's my slope, there's my point slope. I got y equals 3x minus 14. Then I went and I subtracted that over, and I got negative 3x plus y. But then I remembered, oh, the best form doesn't have a negative in the beginning, so I multiplied them all by a negative 1. All right, this one perpendicular is like, whew, okay. So negative 1/2 is the original slope. So what's the slope of, you've read to me my perpendicular line. What's the slope of my perpendicular line? 2. And then I used point slope. I got y equals 2x minus 3. Subtracted the 2x, and there I am in standard form. But I didn't like that this one was negative, so I just multiplied through by a negative, flips on my side.
How is it minus 3 from 13?
All right, now we're on this one. Could be I made a mistake. Let's see, what's the slope? The slope is negative 5x plus 1. So negative 5x? Well, that means the negative reciprocal. What's the negative reciprocal of negative 5?
5. I'm not here.
Nope.
1 over 5.
1/5. Is it? Negative reciprocal of negative 5.
It's positive 5.
No, it's not.
No.
Did you put it in y equal form?
Sure.
Oh, so we forgot. So make sure you're in y equals mx plus b. You can't just take the thing in front of the 5. This is standard form.
Okay.
So then I use point slope. I got this. Y equals 1/5 x. Yeah? You got there? Then I went and I subtracted it out to put it in standard form. I said, ugh, I don't want negative and I don't want a fraction. I multiplied through by negative 5. X minus 5y equals 15. Anybody make it through this thing?
Nope.
No. Barely. We're still alive. We made it. Something. Excuse me? Yeah. Yes.
So you're just doing the point slope formula for both of them, and then you're just trying to find the standard.
And find the correct slope. So if it's parallel, same slope, perpendicular, negative reciprocal slope. But your otherwise process the same. So I think I got another review slide. Parallel line, same slope. Perpendicular lines, negative reciprocal. If you want to know if lines are parallel or perpendicular, look at their slopes. Find slopes of other lines by putting it in slope-intercept form. Parallel lines will have the same slope, and perpendicular lines will have negative reciprocal.